Good morning to all. Today, let us start the next chapter, Motion in a Straight Line. In this chapter, I am going to cover the following topics: motion and rest, distance and displacement, uniform motion and non-uniform motion, speed, velocity, acceleration, distance time graph, speed time graph, derivation of equations of motion by graphical method. Now, concept of a point object. In mechanics, a particle is a geometrical mass point or a material body of a negligible dimension. It is only a mathematical idealization. For example, ball, car, aeroplane, ship, and earth. In practice, the nearest approach to a particle is a body whose size is much smaller than the distance or the length measurement involved. So, any object can be taken as a point mass. When we are considering or discussing the astronomical objects, then Earth can be taken as a point mass. So, motion and rest. Now, ball is at rest. The car is at rest. The man is at rest. Ball is at rest with respect to a stationary man. Car is at rest with a stationary man. Ball is moving with respect to a stationary man. Car is moving with respect to a stationary man. So, what can we say about motion? An object is said to be in motion if it changes its position with respect to its surrounding and with time. So, any object with respect to its surrounding, an object can be said to be at rest. For example, moving car, bus, trains, cricket ball, etc. All the planets revolving around the sun. Molecules of a gas in motion above 0 Kelvin. Rest. An object is said to be at rest if it does not change its position with respect to the surrounding and with the time. For example, mountains, building, etc. So rest and motion, these two terms, they are relative to each other. Object is said to be in motion if it is changing its position but with respect to the surrounding and with time. And if it does not changing its position with respect to surrounding, then it will said to be at rest. An object which is at rest can also be in motion simultaneously. For example, the passengers sitting in a moving train are at rest with respect to each other, but they are also in motion at the same time with respect to the objects like trees, building, etc. So, the reference point is very important. So, motion and rest, they are the relative terms. For example, the man and the car. In respect to each other, they are at rest. But now car is moving with respect to the stationary man. Here the car is at rest with respect to the man and car is moving with respect to the stationary man. Now these two cars, both the cars, they are at rest with respect to the stationary man. Both the cars are moving with respect to a stationary man, but both the cars, they are at rest with respect to each other because they are moving with the same velocity. Motion and rest, they are relative terms. Let us consider or understand the same term again. In the example of motion of a ball and car, man is considered to be at rest or at stationary. But the man is standing on the earth and the earth itself moves around the sun as well as rotates about its own axis. So what can we say? That man is at rest with respect to the earth, but it is rotating and revolving around the sun. So motion and the rest, they are the relative terms. That is why we cannot say that an object is at rest without referring to with respect to any other term. So they are related with each other. Now reference point or origin. While describing motion, we use reference point or origin. with respect to which the motion of other bodies are object. In the previous example, man at rest is used to reference point or origin. We can use any object or as reference point. For example, a car at rest or in motion can be used as reference point. When you travel in a bus or train, you can see the trees, building and the poles moving back. So, to a tree, you are moving forward, and to you, the trees are moving back. So, it depends that which one is moving forward or which one is moving backward. Depends upon the reference point or the origin. So, both you and the tree can serve as reference point, but motion cannot be described without reference point. So, whenever we are describing the motion, the reference point or the origin is necessary. So, what effect do you get when you play video games involving car racing? So, here also the reference point or the origin is very important, and you can feel in these games. Motion in a straight line. The motion of a body take place in one dimension, that is in a straight line. This can be represented graphically by plotting a graph between the position of the body and the time taken by it. This is called position time graph. Origin, unit and direction of a position measurement of an object. So let us study this. Now this is a line where you can see the different numbers are written. 0 is the center point or the reference point. To the left of it, all the terms or the distances, they are measured, taken negative, and to the right they are positive. So the distance measured to the right of the origin of the position axis is taken positive, and the distance measured to the left of the origin is taken negative. The origin for position can be shifted to any point on the position axis. So here, this is the position, or this is the reference point or the position axis, and this point is the origin or the reference point. So reference point can be shifted on this line at any position. The distance between the 2 points on the position axis is not affected due to the shift in the origin of the position axis. That means if we want to find the distance between this point and this point, whether the origin point is here or it has been shifted, but if we are measuring the distance between these 2 points A and B, it will remain same. Now, origin, unit and sense of passage of time. Let us consider that this is the position axis, time axis. Here the point O is the origin, and on the left hand side they are taken to be negative and right hand side taken to be positive. The time measured to the right of the origin of the time axis is taken positive, and the time measured to the left of the origin is taken negative. The origin of the time axis can be shifted to any point on the time axis. The negative time coordinates of a point on time axis means that object reached that point a time that much before the origin of the time axis. The time interval between the 2 points on the time axis is not affected due to the shift in the origin of the time axis. When the same point is chosen as origin for position and time. So this is the axis, distance axis. Here the origin for the position and time both are the same, that is O place. It is the position time as well as origin for the time. Then the position of the point A with respect to distance x is 30 kilometers and time is 6 hours. Point B, x is equal to 40 kilometers and time is 8 hours. C point, x is at a distance 55 kilometer and time taken to reach up to point C is 11 hours. Now, when the different points are chosen as origin for this position and time, then let us see that what will be the value of x and t at for these points A, B and C. Now, in this Here we have chosen the origin for position and time different. Here this point is chosen as the, let us see, that point A is chosen as the origin point for the time, that is 0, and B point is chosen as the origin for the x. X is 0 at B point and T is 0 at A point. Then the O point will be x is minus 40 and T will be minus 6. At C point, x will be 15 kilometers, T is equal to 5 hours. Both the lines, they have the same values. The values between the 2 points does not change. That is, in the upper line, the distance between A and B is 10. Again, on line, second line, the distance between A and B is minus 10 to 0, that is 10 kilometers. The difference between the time is 2 hours in the lower line, and in the above axis, again the difference between the time is 6 and 8, that is 2. So the distance or the difference between the 2 points does not change by changing the reference point. So here origin for the time is at point A and origin for position is at point B. Now distance. Distance means the distance is traveled by a body is the actual length of the path covered by it, irrespective of the distance direction in which the body travels. North. Now this is a boy. He is moving towards east by a distance 5 kilometers. Then it is moving in another direction, a distance equal to 2 kilometers. Then total distance traveled will be 7 kilometers. Now the boy is moving straight towards east through a distance 5 kilometers. Then it is coming back to its origin position. Then he is covering the total distance 10 kilometers. But in case of displacement of a body is the shortest distance between its initial position and the final position along the directions. So let us see, now the boy is moving through a distance of 5 kilometers, then through a distance of 2 kilometers, just like in the previous example. Then the total distance was 5 plus 2, but here the displacement will be equal to 6.57 kilometer in the direction shown by the arrow mark. Again, in the second case, the boy is moving 5 kilometers and then coming back to its origin position, so displacement will be 0 because he has reached to its original position. So the ball is moving between A, C and B. So the length of the path ACB is the distance, but the displacement is the shortest distance between A and B is the displacement. So conclusion about the displacement. Displacement is a vector quantity. It has units of length. The displacement of an object is a given time interval and can be positive, 0 or negative. The actual distance traveled by an object in a given time interval can be equal to or greater than the magnitude of the displacement. The displacement of an object between 2 points does not tell exactly how the object actually moved between these points. The displacement of a particle between 2 points is a unique path which can take the direct particle from its initial to final position. The displacement of an object is not affected due to the shift in the origin of the position axis. So, what can we say? That the difference between the distance and the displacement, distance is a scalar quantity, displacement is a vector quantity. Distance traveled by a moving object body cannot be 0, while the displacement of a moving body can be 0. Scalar quantity is a physical quantity which has magnitude only, length, mass, time. This already you have studied in your previous classes. Vector quantity, you already know that is a physical quantity which has both magnitude as well as direction. For example, displacement, velocity, acceleration, momentum, forces, etc. So the physical quantities, is a quantity which can be measured and expressed in magnitudes value with or without unit. This about the physical quantity you have given the knowledge in the previous chapter, that is units and measurement. So length can be measured and expressed as 5 meter. Relative density can be measured and expressed at 0.8. All these are the physical quantities. Now speed. Speed is defined as the time rate of change of a distance of a time, or speed is defined as the distance traveled by a body in a unit time. All this you have studied in your previous classes. So speed is distance traveled by the time taken. If a body travels a distance s in time t, then its speed is given by v is equal to s upon t. Note that speed is a scalar quantity. Speed is either positive or zero but never negative. Speed of a running car is measured by speedometer. Speed is measured in centimeter per second or meter per second, or in kilometer per hour, which is the practical unit in the life. Practical life when distances and the time involved are large. So uniform speed. This already you have studied in the previous classes. A body has a uniform speed if it travels equal distance in equal interval of times, no matter how small these time intervals may be. The car is moving equal distances in equal interval of time. So we can say that car have a uniform speed, uniform motion. A body has a uniform motion if it travels equal distance in equal interval of time, no matter how small these intervals may be. Variable speed. A body is said to be moving with variable speed if it covers unequal distance in equal interval of time, howsoever small these time intervals may be. Non-uniform motion. A body has a non-uniform motion if it travels unequal distances in equal interval of time. Now from this example you can see that car is moving unequal distances in equal interval of time. Now average speed. Average speed of a body is the ratio of the total distance travelled to the total time taken to cover this distance. So average speed, total distance travelled upon total time taken. For example, let a car travels first 25 kilometers in 1 hour, next 35 kilometers in half hour, and last 30 kilometers in 1 hour. Then the average speed is 25 plus 35 plus 30 upon 1 plus half plus 1, and that is equal to 36 km per hour. Now instantaneous speed means the speed at particular instant, particular time. That is the instantaneous speed. So when a body is moving with variable speed, the speed of the body at any instant is called the instantaneous speed. Velocity. Velocity is defined as the time rate of change of displacement of a body, or we can say that velocity is defined as the distance traveled by a body in unit time in a given direction. So when the direction is in particular direction, then we can take the distance traveled. But if the direction is changing, that means the displacement upon the time gives the velocity. So velocity is equal to distance traveled in a given direction upon time is equal to displacement upon time taken. If a body travels a distance s in time t, it is given in a given direction, then its speed v is given by v is equal to s upon t. Note that velocity is a vector quantity. Direction of velocity is same as the direction of the displacement of the body. Velocity can be either positive, negative or zero. Velocity can be changed in two ways: by changing the speed of the body, or by keeping the speed constant but by changing the direction. Means if the direction of the body is changing but its speed is same, remains constant, even then we will say that the velocity is changing. For example, if a object is moving in a circular motion with a constant speed, then speed is constant, but as it is moving in a circle motion, so its direction is changing continuously, then we will say that its velocity is changing. Now velocity is measured in centimeter per second in CGS system, meter per second in SI system, and kilometer per hour in practical life when distance and time involved are large. Now uniform velocity. A body is said to be moving with uniform velocity if it travels in a specified direction in a straight line and moves over equal distance in equal interval of time, no matter how small these time intervals may be. Note, no effect or force is required to move the body with uniform velocity. So when the body is moving with uniform velocity, then no particular force is required to keep it in the uniform motion. A body is said to be moving in uniform velocity. So variable velocity. A body is said to be moving with variable velocity if its speed or its direction or both the changes with time. Just keep in mind that if the speed is changing or its direction is changing or both are changing, then the speed velocity is variable. Average velocity. When a body moves with variable velocity, the average velocity of the body is the ratio of the total displacement covered by the body to the total time taken. So average velocity, initial velocity plus final velocity upon 2 gives you the average velocity, or the other way, the total displacement upon the total time also gives the average velocity. Instantaneous velocity. So when a body is moving with variable velocity, the velocity of the body at any particular instant is called the instantaneous velocity. Now, difference between speed and velocity. Speed is the time rate of change of distance of a body, while velocity is the time rate of change of a displacement of a body. Speed tells nothing about the direction of the motion of the body. Velocity tells the direction of the motion of the body. Speed is a scalar quantity. Velocity is a vector quantity. Speed of the body can be positive or zero. Velocity of the body can be positive, zero, or negative. Average speed of a moving body can never be zero. The average velocity of a moving body can be zero. Now, acceleration. The acceleration you must also have an idea in your previous class, that is in class 9th also. So, acceleration is defined as the time rate of change of its velocity. Acceleration is equal to change in velocity upon time taken for change. Or we can say that acceleration is final velocity minus initial velocity upon total time. Suppose a body is moving with initial velocity u changes to final velocity v in time t, then a is equal to v minus u upon t. Acceleration is a vector quantity. Direction of acceleration is same as the direction of the velocity of the body. Acceleration can be either positive, zero, or negative. Acceleration of a body is zero when it moves with uniform velocity. Now, acceleration is measured in centimeter per second square, meter per second square, in kilometer per hour square in practical life when distance and time involved are large. Uniform acceleration. A body is said to be moving with uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal interval of time. Then the body is said to be moving in uniform acceleration. Or a body has uniform acceleration if its velocity changes at uniform rate. For example, the motion of freely falling body is uniformly accelerated motion because the acceleration is changing. When the body is falling freely, it falls with acceleration equal to acceleration due to gravity. So it is moving with uniform acceleration. That ball is moving with uniform acceleration. The motion of a sliding block on a smooth inclined plane is also an example of uniform accelerated motion. Here, the object is moving with uniform motion. Non-uniform acceleration motion. A body is said to be moving with non-uniform acceleration if its velocity increases by unequal amount in equal interval of time. Or what body has non-uniform acceleration if its velocity changes at a non-uniform rate. For example, the motion of a car on a crowded city road, its speed or the velocity changes continuously. When the car is moving in a crowded road, then some time its speed increases. Again, at next instant, it has to decrease its speed. So, in a crowded road, it cannot move with a constant speed. Its velocity or its speed changes continuously. So, that is the example of non-uniform acceleration. Here it is, you can see with the example. Retardation or deceleration or the negative acceleration, that is body is said to be retarded if its velocity decreases with respect to time. So velocity is decreasing and the car is moving finally. Car is decelerating to come to a halt. Now graphical representation of a motion, uniform motion or the distance time graph. This is the time axis, this is distance axis, origin. This line shows the distance time graph. So the slope of the distance time graph indicates the speed, because slope here, the slope is AB upon OB. AB gives the distance and OB gives the time, and distance upon time gives the speed. So slope of the distance time graph gives the speed. Speed time graph. This is the time axis. This is distance axis. Speed axis, origin, and this line shows the speed time graph. So the area of the speed time graph indicates the distance travelled. The area of ABCD gives the distance travelled between the time t1 and t2 seconds. Non-uniform motion. This is time axis, distance axis, origin, and non-uniform speed. Uniform retardation, time axis, origin, distance axis, and the graph of the uniform retardation. Now, speed velocity time graph. Time axis, velocity axis, origin, and this line shows that uniform accelerated. OB, A. So the slope of the velocity time graph indicates acceleration. So acceleration is equal to AB upon OB. From the graph it is clear that AB is the velocity and OB is time, and change in velocity upon time gives the acceleration. So we can say that slope gives the acceleration, and area AOB gives the distance travelled. Speed time graph, uniform retardation, time axis, velocity axis, origin. This is the retardation. So the slope of the velocity time graph indicates retardation. Retardation is equal to AO upon OB, and the area gives the distance travelled. Now speed velocitygram, uniform acceleration, time axis, velocity axis, origin. When the initial speed is not equal to 0, that is C point is showing that initial speed is not equal to 0. So slope of the velocity time graph again indicates the acceleration. Acceleration is equal to AB upon OB. Area of the OCAB gives the distance travelled. The equation of the uniformly accelerated motion by graphical method, this you have already studied in class 9 also, but it is in the syllabus for 11th class also, so let us discuss it again. Now first, equation of motion. Now let us see the graph, the time axis, velocity axis, and A is the point, means initially the object is not at the origin. At point A, its velocity speed is u, and at point B, its velocity is v. Now acceleration, we know that change in velocity upon time taken for the change. So we can say that A is equal to BD upon AD, BD is equal to AE, and AD is equal to OC. So we can say AE upon OC. Then A is equal to AE, that is equal to OE minus OA upon OC. So V minus U upon T, and we say V minus U is equal to AT, or V is equal to U plus AT, which is your first equation of motion. Now second equation of motion. Again look at the graph. That area of the trapezium OABC gives the distance travelled, and we know that the area of the graph trapezium is half into the distance between the parallel sides plus sum of the parallel sides. So OC is the distance between OA and BC. So half OC plus into OA plus BC. Let us put the value. OC is time t, OA is equal to u, and CB is equal to v. So half t plus u plus v, half t u plus v. In place of v, we can write u plus at from the first equation. So equation reduces to this. Now rearranging this, we get s is equal to half into 2 ut plus at square, or we can say that s is equal to ut plus half at square, which is your second equation of motion. Now third equation of motion, let us come to again the same graph. The area of the trapezium gives the distance traveled. Let us write it again. S is equal to half OC into OA plus CB. So half T into U plus V. Here V plus U reduces to 2S upon T, and let this equation is first. Now from the first equation of motion, we have V minus U is equal to AT. So this is the second equation. Now multiplying the equation 1 and 2, we will get the result V square minus U square is equal to 2AS, or V square is equal to U square plus 2AS. This is your third equation of motion. Now let us revise the idea of the uniform circular motion, which you have studied in class 9th also. The motion of body in a uniform circular or angular or curved path is called the circular or angular or the curvilinear motion. When a body moves in a circular path with uniform speed, its motion is called uniform circular motion. Note that the velocity changes at each point and at every instant, and hence the body experiences acceleration. Here speed is constant, but the direction is changing, so its velocity is changing. So velocity of a body in a circular path can be given as 2 pi r upon t. Example of uniform circular motion: artificial satellite move under uniform circular motion and around the earth. The moon moves in a uniform circular motion around the earth. So that is all for today's lecture. Thank you and have a nice day.